All right. Welcome to our next video in our series. This is a series on for loops for programming in Java. At this point, you should have already been working with the basics of for loops, but we're going to remind ourselves about the vocabulary. A for loop is broken up into three parts. After we use that Java keyword for, in parentheses, we put an initialization, a test, and an update. They are separated by a semicolon as though they were their own statements. An initialization is a statement that's performed once, and then before we enter the body of the for loop, we test to see if we pass a condition. As long as we pass the test, as long as the result of the test is true, we execute the statements in the body of the for loop, and then we update, usually our initialization. And then we test, and we do the body, and update, test body, update, until eventually we test and we fail, and we leave the for loop. For loops allow us to repeat the basic functions of some sequence of steps. It could be one step, could be multiple steps, but we can perform these statements many times in a row without needing to write by hand all those lines of code. Hugely valuable. The logic diagram looks a little something like this. We recall that all rectangles represent a single statement, right? One step of your algorithm. And that diamonds represent a logical branching, a pass or fail, a left or a right. And so once we perform the initialization, we ask, do we pass the test? And if we do, we loop in to do the body of the for loop. We update, and then there it is. You can see test body update, test body update. We hit the loop until we fail, and then we pop out. By looking at this diagram, we can see one of the three possible situations that can come up with a for loop. A for loop could run a finite number of times, right? It could run 3 times or 7 times or 50,000 times, as long as the updater continues to push the condition so that it gets closer and closer to being false. So it's true, 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 true until the false happens, and then we leave the for loop. That's option 1. I think that's what most people intend when they write a for loop. It is possible to write a for loop that never loops even once. If the variable, if the index that you initialized to does not match your condition, if you set int I to 5, but your for loop only runs when I is less than 3, well, guess what? 5's not less than 3. You failed your condition the first time. You never even get to enter the loop. You never see any of the statements inside the body of the for loop. So it's possible to execute the contents of a for loop 0 times. It's also possible that the way you've handled your index, your initialized variable, and your update means that the condition is never false. It's true forever. And so we can get stuck in one of these infinite loops, the famous runtime error, where you're just constantly going pass, pass, true, 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 and it never leaves, and eventually your program crashes. So that's the basics of a for loop. We're going to start to use for loops to make more complex outputs, but we need to have a good grasp on variables and the visibility of variables throughout our code before we can perform that task. So what we're going to do, oops, that slide got skipped. We're going to do a little demonstration about class constants. So I've made a Java program here in BlueJ, and I want to ask the question, if we say int I equals 3 and int I equals 5, and then system.out.println, I think we can see that Java is going to have an issue with this. Even before I hit execute, we would see that if I try to print out I, Java won't know which I am referring to. Could I be 3? Could I be 5? We don't know. And so when I go to try to compile it and I see, oh, that's not going to work, I hover over, it should give me a note that that variable is already defined. We can't have two variables named the same thing in the same location because it causes confusion. But imagine there was another method, and I'm going to uncreatively name this other method helper method. And I wanted to declare that int I variable here. I want to make it 5 here. Notice, class compiled, no syntax errors. And that's because there's no confusion. When I refer to I in the main method, we know we're referring to this I. It's going to be a value of 3. If I refer to I in the helper method, we know we're referring to this I. It's going to be a value of 5. And this is because of something called scope. It's one of the key words of this presentation. Scope means the areas a variable is seen or visible. Oops, I should make that a comment. It's largely controlled by curly brackets. So what do I mean by that? Well, let's say I wanted to make a variable here, int. I've already used I. I is in scope for this main method. So I'm going to use a different variable for my index for my for loop. I'll use j. J is 0, j less than 3, j plus plus. And then maybe I want to say, I don't know, int k equals 7. Well, now we got 4 different variables going on the screen. We got a couple of i's, we got a j, and we got a k. And the question is, where are they in scope? Where can they be seen? Well, the first I has scope throughout the main method and the for loop. I could refer to I inside the for loop. I could refer to I after this for loop. It would be in scope for either. Let's talk about k. K is the variable that we declared inside the for loop. Well, the curly brackets closest to k are this opener made by for loop, this closer made by the for loop. That means that once I'm done with this for loop, once I've passed this curly and I've moved on, k ceases to exist. It vanishes from memory. And to prove that, I should be able to redeclare k right there. So because the first k only had scope for the for loop, once the for loop was finished, this identifier was free enough to be used again. In general, the practice of naming these two things the same identifier would probably cause confusion, even in a veteran programmer. It's not a great idea. But I did want to write it to illustrate how the scope works. J is a trickier case. J says I was initialized for the for loop, so you might ask yourself the question, where is J visible? Well, J is visible inside the for loop. You're allowed to refer to the index of your for loop in the body of your for loop. That's okay. But just like K, who was declared inside the for loop, once I pass this curly, once I'm done looping, hang in there, Blue Jay, don't crash. Good job. Once I pass that, once I'm done looping, J ceases to exist, so much so that I could declare J here, 42, and it wouldn't be a problem. Scope is something we want to manage to make sure it's clear which variables we're using in what part of our program and why. We ideally would not have there be any confusion. And even though it's permissible to have I up here and I down here, I caution the new programmer to make sure that you're using good and descriptive variables that aren't just a single letter. I have graded a lot of programs where the variables were A, B, C, and X, Y, Z, and they were just as miserable to grade as they were to write, because I was confused and so was the author of the program. All right, the next thing we want to talk about is the term global variable. Global variable. So you might think to yourself, well, what if I need a variable not just in the main method, but also in the helper method? I want to have access to one variable in any of my methods. Well, what you can do is you can declare a variable up here outside of your code, and it would be visible everywhere. I'm going to include an extra word here that I'm going to explain in a second. But to declare this global variable, I'm going to say static int, num equals 77. Sure, that sounds good. And now, anywhere I want to refer to num, I could refer to num in the main method. I could refer to num in the helper method. It's going to be that 77. If I changed num in main, then that change can be seen not just in main, but in helper method, in any other method. This is considered global, meaning it has scope that is visible to anywhere you want in the code. So that's a global variable. Sometimes there are a particular type of global variable that can be really useful. So if a global variable is a variable seen in all places of the code, that's why it's global. There's a special one that includes another keyword called final. final static int, maybe one that you're going to see a lot in projects, is size. And I want you to observe most of my identifiers obey camel case, start with a lowercase letter. First letter of all subsequent words is capitalized. Size was all caps. And the reason we put size in all caps is because it means it cannot be changed. So let me catch up with a couple pieces of vocabulary here for you. So we've got a class constant is a global variable. Well, I'm just going to call it by its name. It's a final global variable. And what does the final keyword mean? It means once assigned, cannot be changed. Okay, well, what does that mean? Well, it means, all right, down here in main method, the main method can see num, because it's got a scope that is global. It can see size, it's got a scope that is global. And if I want to change num, I don't know, num, I don't want you to be 77 anymore. I want you to be 88. I can reassign those values. But if I say, hey, size, you know what, I don't want the size to be 4 anymore. I want the size to be 5. Java will balk and say, you attached the final keyword to your declaration and assignment of size. That means you gave it the number 4. It can only ever be 4. You can't give it a new value. That's what final means. Static is a word that has a lot of significant meaning beyond just chapters 1 and 2 of our textbook, beyond just for loops. Static is really about when a variable or a method belongs to a class of objects and not just an individual object. But that's kind of a concept that's hard to get at this point in the course. So I'm just going to say this. The programs that we've written so far include one class that contains a main method. One of the required words in declaring the main method is static. And because the main method is static, it can only work with variables declared inside of it or other variables that themselves are static, which means that we're going to include the static keyword in front of our global variables so that our main method and other methods can use it. I would like to emphasize there will come a point in this course where we will not use the static keyword as much. In fact, if we overuse static later in the course, it can open the door to a ton of terrible logic errors. So static really means belongs to a class of objects, not one object. But really, in the universe we exist in right now, static means is a part of the class with the main method. That second line is an imperfect definition, but I think it's the one that works based on our comprehension for right now. All right, so we've talked about declaring variables. We've talked about making a variable global. We've talked about how you can make a global variable constant using the final keyword, and the necessity to put the static keyword in front of our global variables so that the main method can use it. In the next video, we're going to talk about how to use some of these variables in nested for loops to create interesting outputs. Thank you.